All right. So while I was drinking coffee on the break, I did have a sudden thought that I should clarify something I said in the first, before we were talking about access to different systems, and I mentioned RFID, and on my Jeep Patriot, when I bought that at a used vehicle, the key fob was long gone, so somebody had paid the Jeep dealer $600 for that, and I mentioned that I'd set up the system myself. And the way I described that might have sounded complicated, but all I did is I took this key and stuck that next to my own one of the readers I have set up with IoT stuff, with my IoT equipment. And I just read what was on this key and copied and pasted that to a writable RFID. The way I said it a few minutes ago might have sounded like I did something complicated, but no, I just did a copy and paste from this. Since I have access to this key, I was able to copy and paste that stuff to a 99-cent rewritable RFID instead of paying a Jeep dealership $600 for another one. Yeah, it is in the chat. It is very, very easy to do that. It's unlikely to happen. There are enough frequencies that kind of like we mentioned with the garage doors are a common one. In big subdivisions, it's a good chance one of your neighbor's garage door openers will open your garage door as well, and vice versa. Your garage door opener will open their garage door. But the odds of that happening, or the two people that can open each other's garage door being right next to each other, is very, very slim. The same thing with credit cards. There's enough that it's unlikely to happen. I just thought I'd make that clarification before it didn't sound like I did something super complicated. Yeah, I have an RFID reader with all of my electronic stuff for the IoT projects, and I just copied and pasted onto a rewritable one. So next up is virtual machines. And I have a few more notes on Thursday. We just finished a big notes on the board section, so I wanted to kind of get in and start doing things with this. Virtualization, the quick version of it, is it's a fake machine. We've been talking about all the different aspects of a machine throughout this semester, right? We started with hardware and the idea of data, what's being stored on that machine, the software to manage and access it, ways to network, more hardware to network it to other machines, ways to secure it, and all those different aspects. And we've been talking about it on terms of like this laptop sitting in front of me. There's a physical device here, some software that's unique to it, and all it seems like a standalone thing. But we can simulate that stuff. We can basically use software to make a fake version of the hardware. Just go in there and change some numbers, tell the operating system that its hardware is something else, and the operating system will run like whatever we told it. As long as we tell it it's something smaller, right? We can't tell the operating system we have a GPU twice the size of the one we have, right? My laptop here has a 4 gig GPU, so I couldn't go in there and tell the operating system there's an 8 gig GPU, because then it would try to act like there was and things would just crash. But if it's smaller, we could do that. And that adds another layer of security or reliability, and lots of different words we can throw in there. Those are the two big ones, right? Another point we've been making this semester is we want to approach these things from the business perspective. If we think of the big system, big business scale system, that knowledge will flow down to our personal usage just fine. So we want to approach with the business perspective, and things like security and reliability are going to be very important from the business perspective. But it gives us a better way to do that. So if I just start sharing my screen, I actually have a whole bunch of systems. So right now we're looking at a Windows system, but I have other operating systems running on here that can run simultaneously. A couple times I've opened up Jamp, but I didn't search for that. I can just start this and click a couple of these start buttons. And now I also have an Apache server with MySQL database running on it. Maybe I'll click Start Mercury as well. I'll click this. So now there's an email server running there as well. So there's two systems running on my computer. Or if I hit Windows X and I open up my terminal, here's PowerShell to the operating system control language for my system, for my Windows system here, and then Apache's system's running. If I push Control 4 on my system, there's also a Kali Linux system running, or 5, I've got an Ubuntu system running on here, and lots of different operating systems running together. Or I can open up this and start up another version of Kali Linux. So basically little fake systems running on each machine. This will boot up. Yeah, boot that up. And notice that little message box that pops up to return to your computer. So as far as the hardware is concerned, I'm on a completely separate machine altogether. It's not connected back to this. Once this boots up, I have to actually hit a key press and push Control Alt to get my mouse back so I can come back over and do stuff on any Windows software. So it's like a little fake machine. And these are ideal for so many uses. Because first off, if something goes wrong, let me go ahead and log on here. And this right here is what your lab is this week. You'll set up a little, you'll install VMware workstation. So VMware is big, powerful software. I'll talk about some more of it in a moment. But workstation is a small local one. It's free to use. You'll just install that on your system. Apple users have to buy an external license for something. So Mac users, you might want to use the GRE lab so you don't have to pay for stuff, but it's a good thing to have on your system anyway. You do not have to buy anything for this class, but Apple users will have to pay for the license on VMware, but it can be a very powerful tool. So there's just other systems. So if something went wrong, right, this is the computer system that gets used, all the files, all the work gets done here. If something broke or went wrong, instead of going out and replacing my laptop, I can just log out of this one and delete that machine entirely. And just close out of here, yeah, power off that machine. And when I restart it, there's a delete button right here. So instead of going out and replacing an entire computer when something goes wrong, do you work on a virtual machine? And if something goes wrong, you just delete it or make improvements later. So like the GRE labs that we've been using this semester, I'm going to talk about what those other two were here very shortly, because that's a new thing that's useful for Windows users. Those GRE labs that we've been using this semester. I'm going to go log into one and point at it while I'm talking about it. I guess I have to go to Ivy Learn and get the link. It sounds like somebody's unmuted or your microphone is really, really low. Did somebody ask a question or were they just unmuted?
I think they were unmuted. I heard it too.
Okay. Yeah, it was soft enough. It sounded like mumbling, so I couldn't tell if somebody was asking a question and the microphone not working right or if it was just unmuted. So way back in module 1, Probably could have put that. I think next time I'll put that link on the home page. That way it's nice and easy to get to, because I've needed to get back to it several times as well. Way back in our module 1 lab, we had the remote access. There we go. And log into the computer labs there at school, the GRE labs. And we have the 2 GRE labs, or any of the computer labs around school would follow kind of a similar thing. But I don't have to worry about which computer knows me, right? Here at home, I have several laptops and they have different passwords and usernames and things. So I have to worry about which computer I'm logging into, but I can click either one of the GRE labs or GRE virtual. Y'all might not see that. And then I can choose just any random computer here. Just any computer in that lab. I just go click log on and hit other user and enter. Which, unlike yours, mine's not frozen. Mine remembers what I did last time, as long as I've been on it recently. They just did some updates, so I haven't been on since they updated it. But it doesn't matter which one of the computers I go to. Any of the computers in that lab know me. And that's because they're not unique computers. What they did is they put together a virtual machine. That was that other link that was there that y'all probably don't see on yours. And then once they got the virtual machine set up the way they wanted, they just put that same virtual machine on every computer desktop sitting in the lab. So they're all basically running the same machine. That's why it doesn't matter which one we want to log into or anything. They're just small virtual machines. And that software I just mentioned, VMware, you can use that right here. If you've used VirtualBox before, that'll be fine. I think VMware is a little easier to use. That's the one I prefer. It's definitely easier to get started with. More things are automated in VMware. You have to set up all the configurations yourself in VirtualBox. But just choose a VMware workstation, and then you'll download and put an operating system on it for the lab. But it's a virtual machine. So here on the computer, on the computer labs at school, we can get in any of them. They're basically every computer in that lab is the same machine, because they're little fake machines. Go ahead and close that. Yes, leave that. I don't think I really changed anything. Some other places for that is, that's kind of the idea of the cloud. Might as well go look at that. So traditionally for networking, we talked about servers and setting up servers and switches and routers and hubs and all the wiring and all those different things to kind of put your network together. But one of the ideas behind the cloud that separates it from traditional networking is there'll be virtual machines. So instead of buying a new server and setting that up all together, if I wanted to set up a new server, I could just come in here and under Compute Engine, create a new virtual server. So it's just software that thinks it's a new machine. Create it. A couple of things I want to point out here. So then we just kind of set things up about it, give it a name so we know what it is, where it's going to be. Oh, this is a big one, so this will probably work. Oh, a medium one, so that'll probably work. When you look at the numbers, if you're used to like your personal computer numbers, the numbers on the server will seem very, very strange because the resources are not being used the same way. A server does not have the same purpose as your local machine. So the numbers are going to, if you're not used to looking at them, throw you off. And then we just choose what type of operating system we want on it. somewhere. Oh, so right now it has a Linux system. And let's talk about, most of y'all are probably either using a Windows or a Mac machine, something from Microsoft or Apple, but you've probably seen a lot of lists with Linux. They're quite popular, but for laptops and desktops and our local machines, really the world runs on Linux, because all of those machines we have are connected primarily through Linux servers. So it's kind of important to know, but we can choose different operating systems. So choose a Windows one, or I guess this isn't big enough for an Apple one. Let me go grab a bigger machine. That should be big enough for it. So we can basically choose whatever type of machine we want to use. Oh, I don't know why that's not on there. There are Mac servers as well. I only see Windows Server on the list, and then a whole bunch of Linux options. I was looking for a list that has that, but we choose our operating system, and I'm going to go back to a small one. What's the smallest? I'll just set up a really small one, because if it's a couple days before I get around to turning it off, I don't want to pay very much money. I don't want to have much adding up on my bill. Choose the operating system, and usually we go with Linux servers. That is by far the most popular ones. So that's why we're looking at Linux virtual machines in your lab this week. Choose an operating system for it to run, and I'll just click these because I might do something with that later. Might throw some ads on it, and instead of deleting it, just throw something that'll catch people's interest in a couple advertisements and see if it brings in any money. And in a few seconds, instead of going out shopping, buying lots and lots of different hardware, going and finding space to put it, making sure there's good connectivity everywhere, in just a few seconds, there's a fake server spun up. It's running on a big, huge, powerful server. Actually, it's on a server farm, so it jumps back and forth as far as the actual location, but it's just software that thinks it's a computer server running somewhere in the world. There's nothing going on here, so yeah. If we try to open it, the server hasn't been started or anything yet. We have to go configure it. I think I can get in this way. Yeah, this will work. And to start it off, we'd go over here and open up the some sort of terminal in order to access that machine, which seems to be taking a long time. I think the Zoom call is slowing it down some. Okay, there we go. It's at least doing something. And now we're back to a terminal, kind of like we've seen. It's just for a Linux terminal. So like the first thing you always want to do on one is sudo apt update, and I think your lab instructions have it as two different things. And I'll type it in one: sudo apt upgrade, and yes, passing all the confirmations. So basically, anytime we do open up a Linux machine, this is the first thing we want to do. We want to check for updates, and if there's any in there, we actually want to install the updates, and then the -y just will pass that through to all the confirmations. That way we don't have to hit yes 50 times when we're starting something up. I'll just run the shorter one. So update, it'll check and see if there's any updates since the last time it was done, and run all of our little terminal operations like we've seen. So there's nothing here, so we can make a new folder. Informatics 109, changing change directory into that folder. Does this kind of look familiar to what we did a couple weeks ago? Oh, did I spell it wrong? Change into INFM 109, actual name of our course. Then create a new folder, a new file, touch class example.txt. I don't know if there's at least this text editor in there. vi class example.txt. So I can go in here and start writing some words. Hello world, normal little example. And list that out, and we'll have the files. We saw some of that earlier, right? Make folders, make files. So we have that terminal access in order to do that on this Linux server, which is just isn't a real server that went out and paid thousands of dollars for and then found a place to keep it and set up some nice permanent connections. It's a virtual server. It's just software that's going to behave as if it is, as if I did go out and spend thousands of dollars and then go spend a bunch of money on a place to put it and really good connections to the internet service provider and all that stuff. So just little virtual machines. In particular, virtual Linux machines are what the world's moving to more and more. And on the traditional servers, they're still mostly Linux. So that's a good one to know. That's what I put in the lab this week when we're looking at virtual machines. And I opened up Google Cloud Platform here. GCP is, some of you all will have to take a class on server administration where you're going to look at cloud platform stuff. In particular, in class, you'll look at AWS stuff most likely, the Amazon Web Services. And you'll go through the training and things like that, but they are not the only cloud provider. There's quite a few, and obviously a big company like Google is also a common cloud provider. And everybody gets $300 to learn Google Cloud. So you get $300 worth of credits. So whatever your local money is, you get 300 of those. People in Europe get 300 euros. People in Japan get 300 yen. And that's money to start learning it, which GCP does use the same standards as AWS. So my recommendation would be learn, when you take the class and learn all the AWS stuff, go ahead and take a look at Google Cloud as well, because they use the same standard. It's just the website is colored differently. They use different colors on their website and the buttons are in a different order, but things will look familiar. And I have been using this heavily to learn it since the beginning of August. And you can see how far I've gotten into that $300. I don't think I'm going to spend $300 in the, oh yeah, $300 in 90 days. So you get $300 in 90 days to go ahead and learn that and just set it up with your Google Cloud. If you just search Google for Google Cloud, right at the top, you should see some cloud.google.com. Just start there. It'll walk you through the steps of setting it up with your Google account and everything. And you get $300 to learn it. Tutorials are built right in. So from pretty much any page, up here in the top right is a button that says learn, where there's just a bunch of tutorials for how to learn it and go through that $300. So everybody has that. That will be very useful for you at some point. I just wanted to kind of point it out and get started with it. Talk a little bit about virtual machines. Very, very useful learning tools. Like this Apache server I set up here. It's a great test environment, can go through, learn a lot about servers on this virtual machine. And in the learning process, we might go through a lot of trial and error, right? Do things incorrectly that mess up the machine. which on a big expensive server would be a major problem. But on a virtual machine, all you have to do is delete it and install one that's not messed up. So they are great, wonderful learning tools. A great thing to get started with. For the Apple people in here, all of the Mac users, most of your classes are going to be oriented towards using Windows stuff. I always test every assignment in the class. I test on every system I have, which is Windows, Mac, Chromebook, and Linux. So every assignment in one of my classes has been tested on all those systems. And if there's something particular, I will let you know about it. But sometimes I think I might be the only instructor that does that. So all of the stuff's going to be oriented towards Windows. So it doesn't hurt to have a virtual Windows machine running on your Mac. And that way you don't have to make those little adjustments for your assignments or learn more than one system. And that's probably the highest recommendation. Is everybody in this class is heading towards an IT degree, and the intent being an IT career after that. So there's a good chance that you're going to encounter different systems when you're out there working in the IT field. So you want to be familiar with them, and it takes time to learn them. So setting up virtual machines now, early in your education pathway, will give you the opportunity to learn it on the different systems. So then you'll be a much better IT person, more well-rounded. That's a good term for it. You'll be a very well-rounded IT person that can work on any system and brag about all your cross-platform abilities when you get into a job interview and stuff at some point in the future. A very, very useful thing. There is a new feature in Windows. It's kind of new. It's one of the last. You have to have a later version of Windows 10. I think from summer or fall of 2021 or later, or Windows 11 it works great on. And that's called a Windows subsystem for Linux. That's what I have going on here on some of my machines. Yeah, so here's a list of virtual machines running here. It's like, I'll just open the Kali Linux. And Ubuntu, I'll open that. So 2 virtual Linux machines running on my thing, but they're not full virtual machines. Like that one I opened with VMware a moment ago. Had to push a keyboard shortcut to get my mouse back from that machine, because as far as the hardware on the laptop in front of me was concerned, my mouse was connected to a completely different machine altogether. So it was completely separate. Windows subsystem for Linux is this new thing they come out with, WSL. It's not a fully separated system, like fully separated virtual machine. So it's still virtual machines. But if I run IP config, I think that was one of the ones in the lab a couple weeks ago. Check the configuration on there. Looking through this list, so there's a network connection that can go to the VMware, and you'll notice nothing. It gets a IP version 4 address, a regular looking address. 192.168.0.1 is the default address for a router. So anything with that address is usually that starts with 192.168 is looking at the local router. Here's my regular connection. Down here, it says there's an Ethernet cable plugged up to my computer, and y'all can't see my laptop, but there is no Ethernet plugged up to my laptop. Actually, I think this laptop doesn't even, oh, this one does. Never mind. I was thinking this laptop might not even have an Ethernet port, but there's one on there, but there's no Ethernet cable plugged up here. The IP address is different than the 192.168. So it's not going through the local router. And there's the Windows subsystem for Linux. So it's virtual machines, but when we activate them, we automatically get a network on our Windows system. So our Windows computer is already networked to these. If I pull up the IP address here, I'll just pull up the IP address and right there, 172.20. That highlighting makes it hard to see. But right here where my mouse is at, I'll highlight it, but then that purple is hard to see with the highlighting. So right there, you'll see 172.20, then a couple other numbers. And the first two parts of that are what the address I pointed at over here. So the Windows system already knows about them as far as network machines that are connected across the network. But the Windows, it's a full subsystem. It's even more than the network. If I listed out all of the mounted drives, so basically list out every hardware storage drive that the computer knows about, has the C drive, so that's the Windows machine. Whenever I keep my machine synced to Google Drive. So if I open File Explorer, I have direct access to Google Drive. So when I did the subsystem, that access passed on down. WSL, so that's the Windows subsystem for Linux. So if I list that out, list out what's in the mounted drives, the WSL, and I know what the next level is. There's a folder in there called instances that I went into. But if I go in there, I'm on the Kali machine here, but it also knows about the Ubuntu system. So they're virtual machines that know about each other. On that VMware, it is a completely separate machine. You have to basically hook them up like you would two machines on a network. But WSL, all the machines know about each other. They can interact. I'll come over to start. Yeah, I'll look under all apps. You'll see there's a folder here called Kali Linux. And at the introduction level, a lot of y'all might not recognize what I'm doing here, but some of y'all might know what this sentence means. Linux software can run natively on your Windows machine. So this is Linux software. You'll notice things look a little bit different than the Windows system. So like it's coming from a different operating system. Menus are set up different. And it's actually Linux software running natively on the Windows machine with the Windows subsystem. So for Windows users, that is a very, very nice one to look into. Oh, yeah, and I guess over here in File Explorer, I have direct access to those machines as well. So everything's all connected, whether I want to use it as a network or separate parts of the current machine. It works both ways. So that is a really useful feature to have in Windows. If you want to turn it on, there's a short way and a better way. The short way, I'll type that first. If you open up your terminal, like PowerShell, and type WSL-install, that will activate it and put an Ubuntu system on your machine. That's the short way. There's a better way. It's a small Ubuntu system, so you can't put the full version of Ubuntu on there. But once it's activated, you can extend it. If you just want to give it a try, you can do that. Just WSL-install will do this, the small version. The better way to do it is if you go to the start menu and search for I have no idea why VMware just opened. And search for turn Windows features on or off. Or if it's hard to remember that one, if you start searching for features, just remember you want to adjust Windows features. Well, you do have to spell it correctly. If you start searching for features, you should see turn Windows features on or off. I always remember it with the full sentence because that does make sense. So turn Windows features on or off. And if you weren't aware of it, there's a lot of things that your operating system can do that are not on by default. They try to generalize it and activate the most common ones because obviously anything we do that's going to be more is going to take up more usage. And on this list, if you scroll down to the bottom, it's in alphabetical order. Somewhere in here, there's a checkbox for Windows subsystem for Linux. All you have to do is click that checkbox, and anything here you have to restart your machine. But turn Windows features on or off, hit that checkbox for Windows subsystem for Linux, and then restart your machine. And then you can start installing systems. You do have to make sure virtualization is enabled, which you will also need to do for any type of virtual machine. So virtualization, you have to give permission for your machine to run virtual machines. You can check it for about 5 years. That's been the default on systems. So everything should be ready to run virtual machines. On a Windows system, you can check by going to the task manager, Windows X. And then in Task Manager, if you go to the Performance tab, which by default, you're probably looking at it like this, hit More Details, and under Performance, where you get the little graphs, on the CPU, there's a list of things, and in that list, it will say Virtualization Enabled, which I apparently can't highlight anything on this one, but you'll see about halfway down, it'll say virtualization. It'll say either enabled or disabled. And if you have to enable virtualization, that's a change to the BIOS, basic input output system, BIOS. And changing that is fairly straightforward. Pretty much every machine, whether it's a Windows machine, a Mac, a Linux machine, you'll restart it and then hit a certain key while restarting. The thing is, which key you hit depends on who manufactured the PCB the motherboard components are attached to. So that main circuit board inside your computer, the key you need to hit to access BIOS depends on who manufactured that. So really, even looking up the laptop model, so like if I was to look up BIOS on HP Pavilion, which is what I'm on right now, I would just get a list. It's not F10. On mine, it's Escape. If we went through there, we would find that there's actually, that goes to a list of keys you can try. And on any of your systems, it's going to be like that, because even a particular model of computer might have had different people manufacture that, the actual PCB that the components are soldered onto. And it's the manufacturer of that, of the printed circuit board, not any of the components attached to it or the software running on it, that defines how you get to the BIOS. So you might have to do a little bit of Google searching if virtualization is not enabled, and the ones in the GRE labs ready to go. But it's something that will be very, very useful for you, and you probably want to look into. at some point on your way through education. A virtual machine, you can experiment freely, and if something goes wrong, you can just delete it and install a new virtual machine that works correctly without messing up your own system. But just Google Access BIOS, Access BIOS, that's a basic input output system. So the hardware, and you'll see a list. It's probably something in the top row. Whenever you'll restart the machine, and when it first starts up, you press one of those keys in the top row, and it'll enter a specific menu, a hardware only menu. So your mouse probably will not work. You have to use the keyboard to get around it, and you might have to try a few different things. Like, I just pulled up the one for the computer I'm on right now, not long after I got it. And it said push the F10 key, but the F10 key didn't work. So then I tried some of the other ones. F4 is very common. So is the delete key and the escape key. And on this particular computer, I have to hit the escape key to get to BIOS when it's restarting. So you will have to pay attention to your computers. So sometimes it, like, even in you have an office full of computers you're the IT person for, they're all the same model. They were ordered at the same time, but when the manufacturer put them together, they use PCBs from different distributors. So to get into the BIOS on the machines, you might have different keyboard shortcuts, even though they seem like all identical machines from anything we can see. But for several years now, virtualization has been the default on most machines. So you want to install that. And I guess before we wrap up, we're gonna talk about this more before long. For Windows users, I highly recommend turning on that Windows subsystem for Linux. It's a very, very useful thing. The world runs on Linux. We all have Windows and Macs, but those Windows machines and Mac machines and every other machine is connected through Linux servers. So it's kind of important to know those. To get the operating system, we look for a file with the ISO extension. I'll just Google this. It's a file that contains ISO is a file that contains an operating system. So Kali Linux is a distribution of Linux that's very popular for cybersecurity people, really for ethical hacking, really for any hacking. It has lots and lots of tools built into it to make it easier to hack into stuff. So for the lab, if you want to Kali Linux, just kind of go here to their official page or search for Ubuntu, and on the download page, when a lot of people look at it, they first want to click this one that says virtual machine. That's a pre-built machine that's ready to go. So you do not want that one. You want the image. You want the actual ISO file. So you'll just click that, and you'll jump down here and grab one of these files. The one that says installer will work. It's a good starting point. You just download that and make sure the download says ISO. And also notice the size of it. 2.9 gigabytes. An operating system is a little bit larger than most of the software you're probably used to downloading. So it takes a minute to download. I'll cancel this. We'll go through all that on Thursday, but I wanted to go ahead and I figure some people might want to get a jump start on the lab. So make sure the file you download has the ISO extension, because that's what that's the image of an operating system. And then the lab has step-by-step setting up the virtual machine. And that other one that I just mentioned, for those on people using Windows, if you go to turn Windows features on and off and activate the Windows subsystem for Linux, which It also doesn't hurt to click this box right here for hypervisor. That's graphics acceleration. So if you don't have a GPU or you have stuff that, or you would like, you have more stuff than your GPU can handle at any given time, that will modify your CPU so that it can handle GPU calculations better. They're optimized for different things. CPUs are optimized for lots of complex calculating. I guess that's one way to put it. Lots and lots of complex math equations and lots of calculations that are needed. And GPUs are optimized for small instructions, like well, for screens or graphics, turn this pixel on, turn this other pixel off. Those simple instructions are what run through a GPU. So they're wasteful to run those instructions to a CPU. So hypervisors help with that. Once you have that activated, then you can just go to the Microsoft store and grab Linux from there, and it will install right on your system for the WSL. Once it loads. Well, that took a long time. You just search for Linux. And then you'll get these different versions. So like Kali Linux, or somewhere in here is Ubuntu. Or you can find Ubuntu. Notice there's different versions. Oh, it looks like I have a small one right now. Really, you want the one with the numbers. That's the full version of Ubuntu. For Windows users, that will definitely be a very useful thing. You just turn Windows Subsystem for Linux on, and then go to the Microsoft Store. I guess if you do the short way, WSL -- install, it puts the small version of Ubuntu on there, and then you can go over to the Windows Store and grab any other version of Linux, like Kali Linux, and all those, get those set up. Then on Thursday, we'll look at the actual VMware a little bit more, talk some more stuff about virtual machines, but very, very useful tools. A fake machine, and we've been talking about machines all semester, so you kind of know, you should kind of know what to do with it once you start it up. And it helps add a layer of protection between what you're doing, the work you're carrying out, which is pretty much all software based, right? Except for us actually pushing the buttons on the keyboard, everything the computer does is software based. So when we virtualize it, we're working in that fake machine, which adds a layer of protection against the real machine, which is expensive. And if something goes wrong, we delete the fake machine, put a new fake machine on there, and our real machine, the one that cost a bunch of money, is still perfectly safe to use. So the main topic for this week, the virtualization, is a very, very powerful tool that will be immensely useful for you throughout your education and beyond. We use those a lot. For Apple users especially, most of your instructors probably did not check to see whether the homework assignment for their class can be carried out on a Mac or not. They just gave Windows instructions. So a quick way around that, to be sure you're ready to go everywhere, is just set up a virtual Windows machine running on your Mac. And then you have both systems at once. Two is better than one, the old saying that way. Or include a Linux virtual machine, and really that cross-platform thing will make you a more well-rounded IT person and be beneficial for everybody in this class. But there's a lab to walk through there. What do we got left? About an hour's left of time, so you can start looking at the lab, discussion boards. We're coming near the end of the semester, so it's probably a busy time. You probably have lots of work in your other classes and all that stuff. So as normal, I want to make sure there's plenty of time to do that stuff. your calendar should have our time blocked off till 3:50 to say and learn IT during this block of time. So please use this time productively. As always, text messages and Ivy Learn messages are the two things that make noise on my phone, and we'll be ready to jump back on a Zoom call in a split seconds time from now till 3:50. And then I'm going to head up to campus for my evening class. But please use our time productively. Otherwise, does anybody have any questions before we wrap up?
No questions.
All right. So if you have any questions, let me know. Otherwise, I'll see y'all on Thursday, and we will kind of walk through the steps on that virtual machine, looking at Kali Linux instead of the one in the lab. I think the lab goes through Ubuntu. See y'all Thursday.